Good afternoon, madam.
Sir, good afternoon, sir.
So let's start.
Sir, 2 minutes, sir. We will start. Participants are joining. We can take two or 3 minutes of time, sir. Later we can start, sir.
It's 11:45, madam. I have some other engagement actually.
Yeah,
So
actually,
anyways, let's wait for 2 minutes. Okay, 2 minutes.
Yeah, sure, sure. The session started. And remove sir profile. Vishnu sir. Vishnu sir. What's profile reading? Good afternoon, participants. Welcome to the second session of today's FDP, Day 3 FDP, that is an application of emerging technologies in business. Today we have Dr. Pramod Kumar Mishra Garu, who is going to deliver his lecture on supply chain analytics. Before going to start the session, we'll have an introduction to the profile of Dr. Pramod Kumar Mishra Garu. I request Vishnath sir to present the profile of resource person to all the participants.
Okay. Thank you, ma'am. Good morning to all participants. So I would like to give a brief introduction about Dr. Pramod Kumar Mishra Garu. So he is an assistant professor in School of Management Studies, University of Hyderabad. Prior to this, he worked in the Geetam School of International Business, Visakhapatnam, and Gandhi Institute of Technological Advancement, Bhubaneswar. And to his credit, he is also a postdoctoral fellow at IIM Bangalore, subsequent to his PhD at University of Hyderabad. He has published papers at national and international journals of repute, and some of them were indexed or listed in Scopus and ABDE, and also presented a number of papers at national and international conferences in India and abroad. Dr. Mishra has conducted several training programs and organized hands-on sessions in machine learning, optimization techniques, research methodology, and so on, for both faculties and research scholars. And he published, and his interest areas are the operations, supply chain management, supply chain analytics, focusing on the predictive and prescriptive mathematical modeling. So hope today we will learn many things relating to the supply chain analytics. So this is what about a brief introduction to Professor Pramod Kumar Mishra Garu. So welcome you, sir. A warm welcome to you for this session. And I will hand over the session to Dr. Varalakshmi Garu.
Thank you.
Thank you, Dr. Krishna, sir. Thank you for your wonderful words about Dr. Pramod Kumar Mishra Garu. So we welcome you, sir, to the 1-week FDP on application of emerging technologies in business, which is organized by JNTUA School of Management Studies. Hope the participants will have a great time with you, and they will learn and excel their knowledge in the area of supply chain through your words and through your experience and through your insights related to supply chain analytics. We welcome you, sir, with wholeheartedly. Thank you, sir.
Thank you very much, madam, and thank you, Dr. Vishwanath. It's a privilege to get associated with this particular workshop. And as madam said, and Dr. Vishwanath said, I am into basically OM and QT area. This is my teaching as well as my research area. So today, broadly, I'll be talking on few things from supply chain management, and there are two analytical aspects. One is based on the predictive model, and the second one is a little bit on solving a particular problem that is a network problem just by using some trial and error method. And there is one thing that I just wanted to highlight, but time will not permit, so that itself will take some 1.5 hour session. So what I'll do is I'll share that Excel sheet with all of you. Maybe you can see at a later stage. That is based on the solver model of the network, right? Or you can say solving the network model using the Excel solver. So that is the thing I'll be sending. Time is too short, and let me see how far I can give you the kind of orientation of lessons, how far I can sensitize you on this particular aspect. Of course, this is not a very new thing. We have been discussing about the predictive models, optimization based models, and so on. So this is not a new thing. Some of you may be already into this. So let's join together for a mutual benefit and take home from this particular session. So let me start the session. I'm sharing my screen. If you have any questions, you can just ask at the end. I may be in a hurry, so you can just say to make it a little slower, wherever it is essential, because time and the topic, according to me, there should be some proportionality in between. So we have 41 people currently. So before I start, I thank Madam and JNTUA Anandpur for giving me this opportunity to speak to you on this particular occasion. You are able to see my screen?
Yes, sir.
Is my voice clear?
Yes, sir. It's audible, sir.
Yeah, thank you. Good morning. 2-3 minutes we are away from the afternoon. Okay, so supply chain analytics. The supply chain plus analytics becomes supply chain analytics, right? Supply chain, all the stakeholders involved in a process to deliver goods and services with the customers. And analytics is nothing but your systematic analysis of the computational data. As per the dictionary meaning of this, systematic analysis of the computational data, that becomes your analytics, right? You talk about descriptive analytics or predictive analytics or prescriptive analytics, whatever you say, it's all part of that, right? So supply chain and analytics coming together is supply chain analytics, and moreover, the analytics of the supply chain becomes supply chain analytics, right? There are a few things I'll be talking here in this particular session so that it can sensitize some of you to take this as a kind of a research topic, or maybe for the paper publications. Those who are already into this, they may be familiar with certain things. Those who are not familiar with it, or those who are the research scholars especially, if any in this particular event, they will also have a good take home for their research. But this is actually the area where not many people come to do their research. We see either people are interested in marketing, or maybe HR, or maybe in finance, but hardly there is anybody in the supply chain and operations, quality, simulation, and things like this. Right? So without taking much time on this aspect, let us get into the work. Sometimes this Google Meet is not working properly. Yeah. Okay. So you know that the supply chain and the supply chain management and the logistics, right? There are a few things that I'm not getting into it. As far as the analytics is concerned, we are basically particular about few things. That is the key decisions that we take in the supply chain are basically this. When we think about the supply chain, we first of all think about the design aspect of it, right? Where the facilities will be set up, right? And what transportation options are available, and what will be suitable for the deliveries, right? And most important thing here is when we talk about the supply chain, we generate the value that we deliver to the customer, and the value that we generate is nothing but your supply chain surplus, right? So supply chain surplus or the value is nothing but your the supply chain, I can say the revenue minus the supply chain cost, right? So these are all aspects related to the supply chain operations reference by Council of Supply Chain Management Professionals USA. Those who are interested more into the supply chain performance measurement can probably get into those aspects, and that site at least to know certain things more about it, how we can measure the supply chain performance. Now, the supply chain performance, when we talk about the performance, of course, we have the cost, and we have the reliability, and the asset, and the warranty, the delivery related aspects. These are the key issues in the supply chain that we basically use for the supply chain performance measurement. These days, supply chain management performance measurement is becoming a very complex task, because not only a typical supply chain is competing with other supply chains. Sometimes it has been seen a typical supply chain is also a part of another competing supply chain, right? So we can see there is some kind of what we should say here, intertwined supply chain process that is happening in the process, right? So this is very good research area these days. Maybe we can think about it, those who are interested further. But these are the two aspects in any supply chain, or maybe in any supply chain performance measurement. They're basically the services and the cost, right? We use services very loosely. What is a service? Is maybe if the certain percentage of the demand is fulfilled, that is a service. No, that is not the service. Service is something which takes into account the uncertainties, which takes into account the safety stock, which takes into account the economic order quantity and so on. So you can calculate in a typical cycle, maybe a procurement cycle or a manufacturing cycle or maybe a replenishment cycle, what is the probability that the customers will come in for buying something and the product is available. Okay, or in another sentence that we can say, what is the probability that demand during the lead time in a typical process or in a typical cycle, there will be some stock available, or another way you can say the demand during the lead time is either the reordering point or maybe less than the reordering point, right? So that is the service. And not only that, it is again a key aspect. Not only that, it's a very, very complex term here. Okay, people use very loosely or maybe vaguely, but in operations term, it is not that easy. It is not that easy, right? So further, you can say it is also depending on the filling rate. It also depends on the expected shortage in a typical cycle and so on. Maybe those who are into the supply chain management maybe knowing about it. I do not want to get into too much details about it, but it's a good idea to see what is the service that somebody is doing. Now the question comes, if the supply chain is a manufacturing supply chain, then what is the need for the service? Yeah, there is a need for the service. Why there is a need for the service? Because while delivering the good may be a tangible item, but you need to ensure that the product is available, product is delivered on time, product is not damaged. This is a part of your service. Okay, so in addition to the tangible item that you have, so it's very, very essential to see to that the product is delivered on time and according to the requirement, right? That is the service that you are doing. So then the question comes, how do you calculate this particular service? So what is the level of the service? What is the expected shortage in the process? So and so on, we need to calculate. So this is not very simple term. People, those who are into this or people who are trying to do some research on this, is a good idea to get into the services, right? Even though it is a manufacturing supply chain. Then on the other hand, you can say if the supply chain is a service supply chain, is there a need to concentrate on the tangible part of it? Yes, that is also equally important. To see if it is a service, then tangible part of it is also highly crucial, right? But things are very, very critical. Sometimes, whether it is a manufacturing or a service, we need to ensure that the product or maybe the service is delivered at the right time, at the right location, and with the right quantity, right? And maybe with the right price, right? So this is one way of doing other things, service. Then comes the cost. There's too many things actually. There is every single point of what you see here is a chapter. Every single thing that you see here is a chapter. So I'm just giving you the essence of it, and I'm taking you to certain things in the analytics. Then the cost. Cost is one thing that that the supply chain cost. Okay, so supply chain cost we need to calculate. It could be procurement cost, production cost, storage cost, delivery cost, right? Maybe distribution cost, transportation cost, ordering cost. All these things will be coming into picture. That's the cost, right? Now this cost can be calculated very scientifically, and this also can be calculated scientifically, right? So now when we talk about these two things, we are basically meaning two aspects of the supply chain. One is called as the efficiency viewpoint of the supply chain, and the other one is the responsiveness viewpoint of the supply chain. So efficiency and the responsiveness, right? So efficiency, the supply chain, those or the people who are trying to become efficient in the supply chain, they mean cost. And cost is nothing but your the money or the dollar or the rupees what you spend, that we need to minimize. So to maximize the revenue, we need to minimize the cost. Okay, and to maximize the profit, we need to minimize the cost, right? So this is actually one thing that we need to think about. So if you see these two aspects, one is here and one is here. So the entire supply chain is working on these two aspects. Okay, you can say, so we purely concentrate on the cost and ignore the service? No, that's not a good idea. Then shall we purely concentrate on the services and ignore the cost? No, that is also not a good idea. Then what is that we need to do about it so that we can minimize our cost and at the same time can maximize our services and the revenue and so on, right? So this is actually very, very critical thing that we need to think about it, okay? And please remember, there is no simple solution to this. There is no simple solution to this. We need to think about it. It is a very, very critical thing, and to make it a little more simple, I am talking about something called push-pull boundary in the supply chain. To what extent the supply chain can be pushed and to what extent supply chain can be pulled. So pull is basically based on it is actually reacting to an order, and push is basically anticipating an order, right? You produce something and store it in the warehouse and wait for the customers to come and buy it. That is push. And you wait for your customers to come and order, and then you start your production and all other things. So that is basically part of your pull. So push and pull. So the supply chain has to shuttle between the push and pull. Okay, it can be completely pull or it can be completely push. Okay, that depends. But most of the times a proportion, maybe 70-30, 30-70, or maybe 60-40, 40-60 kind of thing will be the right idea, or maybe the kind of right mix for a typical supply chain, right? So this is one thing that we need to think about it. This is actually another critical point here, and that has a lot of analytical angles, right? Then whether to buy or make, that is again a critical decision for the supply chain. You know that buying in terms of the sourcing analytics, making is nothing but your making analytics, okay, buying analytics and making analytics. So we need to think about it. When you buy it, then what are the things we need to think about it? When you make it, what are the things we need to see? Of course, we have the price, the supply terms and conditions, the quality level that we basically expect from the suppliers to come in. So all these things are related to buying or making, right? Then if you decide to go for a buying, then immediately comes the sourcing. So you need to have a single supplier or a multiple suppliers. Okay, you need to have a single supplier or the multiple suppliers, or maybe a few suppliers. What is that we need to do? Whether you'll be going for onshoring or offshoring, right? These are the certain things we need to again think about it, and thus purely your sourcing analytics. So here you can say sourcing analytics, you have making analytics, then you have planning analytics, then you have delivery analytics, and so on. Then you have your inventory, then comes with the inventory. So what is the right inventory that we need to have at what stages? Okay, and what should be the kind of a relationship between the inventory stages? Okay, otherwise there will be a lot of bullwhip effect. Bullwhip effect is a phenomenon that the distortion of demand order quantity amplifies upstream. So that is what is your bullwhip effect. Similarly, on the reverse, you have the rippling effect. So demand order distortion that amplifies downstream, right? So these are the certain aspects we need to think about it, right? That is again delivery related aspect, and inventory plays a very, very crucial role there. And when you talk about inventory management, we talk about the ABC classification, or maybe the classification of the inventory. We talk about the economic order quantity. We talk about the minimum order quantity. We talk about what is the safety stock or the buffer stock, right? We talk about the again, inventory is very much related to the services, right? And safety stock is very much related to the services. Services is nothing but the service level that you basically deliver, right? So there are a lot of statistical aspects behind this, and people need to get familiar with the normal distribution and probabilistic distributions and so on. So this is one thing. Then comes this is a very recent phenomenon. A lot of things are happening on this particular aspect. So how can the supply chain become flexible and resilient? In the current situation, people expect the supply chain to become resilient, right? how quickly we can come back to our normal position so that we can start our normal business, how much time it takes for a typical supply chain to come back to its normals. That is resilient. So resilient is basically a kind of a short-term phenomenon, and on the contrary, you have the survivability, or you can say the viability of the supply chain, that is again the long-term phenomenon. So these are the few things, and I can say these are the key decisions, not only the key decisions, these are the key research areas. Then a typical scholar should think about it and do something about it, right? Then comes, as I said earlier, the one thing that is faculty, those who are teaching the subject may be familiar with this particular chart. What I can say is, when we talk about, I'm not getting into too much about it, I'm getting into two aspects. When we anticipate some demand in a typical marketplace, okay? So we can say demand may be certain, like staple food, rice, wheat flour, milk, egg, fish, or maybe vegetables. So these kind of items has, you can say, the certain demand, right? And where are the uncertain demand coming from? Like, let us say the fabrics, garments, automobile, right? Electronic gadgets. So demand is uncertain. Now the supply chain is struggling between the two. What is the analytical aspect the company should take into account, or what is the type of analytics that can be done in the process? Okay, so what is the best thing here is to estimate the demand, and demand can be of two types. One could be the push demand, and the other could be the pull demand, right? And the supply chain has to shuttle between the push versus pull, right? And when we talk about the push, then certain things are known. Like if I say a normal customer will be, or maybe consumer will be taking, let us say, 100 gram of rice maybe every day. So that can be certain. But how often someone will be buying a car is a very complex question to answer. Maybe every 10 years or maybe lifetime one car, right? So it's possible, uncertain. So it's very uncertain. Now, these are the two things, when the certain demand, uncertain demand. So what is the statistical aspect here is somebody can calculate the standard deviation of the push process and the pull process, and the other things can be clear. What is the kind of uncertainty that is there in the process? So if the standard deviation is very high, and or you can say the standard deviation in comparison to the mean is very high, then probably we can say there is a very high uncertainty in the typical supply chain. So we are here. Then comparing to this, and here it will be the standard deviation of the mean, or I can say the coefficient of variation, it will be very much lower. So we can say the demand is very, very short. So uncertain demand, and here is the certain demand. Now, here is basically the, you can say, they are the two extremes. In between, we have the implied demand uncertainty, right? Implied demand uncertainty spectrum. So that means we are shuttling between these two. Now, the thing here is, how can we assess the uncertainty in a typical marketplace, right? One of the good ideas, like a very simple way to do the things, like a market segmentation. Okay, market segmentation. How do you do the market segmentation? That you think about it, maybe geographical or maybe taste preferences or demographic segmentation, whatever. So we need to figure out what is the kind of uncertainty that is related to this. So people are not alike. Some people may be quality conscious, some people may be price conscious or price sensitive. Some people may need price and quality in a typical product. Some people do not want price, do not want quality, they need timely delivery. So what is that? We can segment the market. And after the segmentation, certain things will be very much clear. Then what happens when you segment the market? Let us say, there are three different markets and we are segmenting. Okay, the market is segmented, first market, second market, and the third market. And what happens here is we do analysis for this market and this market and this market separately. Then we can have a kind of aggregation for the total market. Now what happens, this is a good idea to understand the implied demand uncertainty and to segregate the markets. But at the same time, we say that the aggregated forecast is better than the disaggregated forecast. Then what happens here is you do a forecast, right? and you do another forecast here, right? You do another forecast here, then you do another forecast here. Now what happens is your forecasting error may be higher comparing to the aggregated forecast. What is the aggregated forecast? You are 1 plus 2 plus 3, then you go for the forecast. In the sense, how to add this 1 plus 2 plus 3? Yeah, I am talking about the data. You take the data and you classify the data according to the market or maybe some preferences or maybe demographic profile. You split the file, then do the analysis, go for the forecast, go for the forecast, go for the forecast. Then you do a common forecast. Then you compare the results, right? And you see. So the typical uncertainty that is coming from here, the typical uncertainty that is coming from here, the typical uncertainty that is coming from here, the typical uncertainty that is coming from here. So sigma 1, sigma 2, sigma 3, these are the 3 different uncertainties. So these 3 uncertainties, and there is bigger uncertainty. There is a bigger uncertainty for the entire market. So we can compare now. We can compare now in comparison with this aggregated forecast or aggregated standard deviation. What is the fluctuation that is happening in a typical market? So this will give us some kind of idea to understand what is the implied demand uncertainty. So this is actually one thing which is not very simple. Not very simple to understand, and sometimes people ignore. But there is a lot of potential in this for the future research. Okay. So now on the contrary, we have on this side we have the cost reduction. Okay. When you know your demand is certain, your production may be certain, your capacity may be certain, your manpower may be certain, material can be certain. So everything certain. Then you can minimize your cost here, or you can exploit the scale economy. You can exploit the scale economy. So when you exploit the scale economy, then what happens is you can minimize your cost. When you minimize your cost, then of course you are here. Right? You become efficient. But at the same time, you are not really worried about your timeliness, right? Because this is, it's a routine. It's a routine kind of activity. You produce, somebody will buy it. You produce, somebody will buy it. Somebody will buy it, you produce. So it's like very, very closely related. But here what happens, you don't know, you produce, there is no buyer. You don't produce, there will be buyer. So very, very uncertain thing that is happening here. So that means you are here. So the other point in time, you are just shuttling between these 2 points. You are shuttling between the 2 points, right? Now the question is, if you are here, then you are fortunate. Okay, you do not really think about your timeliness and all that. Of course, you can do whatever you want. You have to pay a little attention to the timeliness part of it, responsiveness part of it. But more than that, your focus is on the cost, right? And here, what is your target? Your target is not the cost. Your target is the timeliness. Okay, you know your customers can pay for it. Okay, customers have the purchasing power and they do not really worry about the cost. Then what you need to do is here you need to quickly deliver. Okay, so that means how fast you can deliver. This is another extreme that you need to do. So typical supply chain, those who are not familiar with it, I can say, let's say this is a grocery supply chain, you are here, and there is a garment supply chain, you are here, right? Or maybe you can say jewelry or maybe diamonds or whatever, you are here, right? And other people are struggling between the two. Or if I say another extreme, that is a very very premium cars, you are here, and grocery vegetable supply chain, you are here, right? So other people are struggling in between the two, right? So this is a very, very critical aspect of the supply chain. Normally we don't consider this most of the times, and we just skip the certain things, but it is actually very, very complex thing to think about it. And because these days there are a lot of complexities that is coming up in the supply chain, we need to see how things are really happening in the process, and every single minute aspect of it we need to closely watch and analyze from the viewpoint of the supply chain analytics. Not to take too much of time on this critical part of, or you can say the metric part of it, you can just get into this paper I have quoted, and there is a reference for this. So what is that? As I said earlier, according to the score metrics by CSCMP, Council of Supply Chain Management Professionals. CSCMP, you can just get into this website, you will have a lot of information. So quickly, there is delivery performance metrics, or the quality of the delivery, then your flexibility and the responsiveness, cost and the asset, right? So we need to focus on this part of it, right? So typical delivery performance to a commit date is 90% is expected, and if you are a good performer, then probably 95%. Now you know this average performance, and the study was done somewhere abroad, and 90% delivery performance to the commit date is not a simple task, right? Your supply chain has to be very agile and very responsive, right? And I don't know, we may have to go for a kind of empirical work here. Then you have the filling rate. Filling rate is 96%. Okay, good value of the filling rate is you want 100, I will give you 100. Okay, so you want 100 first time, you want 100 second time, then I have to give 100 both the times full. Then I can say my filling rate is, let us say, 100%. So 100% is virtually impossible. Here actually 96% to 98%. Still it is a very complex task, right? As far as the deliveries is concerned, 96%, it is like you can say 3 sigma level. It's a 3 sigma level, and this is I can say this is a 2 sigma level. Here it is almost 2.5 sigma level, right? Then the perfect order fulfillment, how many orders are there? How many orders are delivered in full? How many orders are delivered to the committed date? Then you have to find this ratio. Okay, 85%, here is 90%. So the lead time, this is another critical concern. Lead time is a very critical part in the bullwhip effect. Okay, so most part of the bullwhip effect comes from this particular aspect, that is the lead time. So lead time, you give the order, it could be the delivery lead time. So delivery lead time is basically part of the manufacturing lead time, and you can say delivery lead time will be more when the manufacturing lead time will be more, right? Or the production lead time will be more. So the lead time, and here it is 5 days. 5 days means it's too less. It's too less. Okay. In the context, what we can say is that the supplier is there at let us say at Chennai, and there is a production farm in, let us say, Gurgaon, then the delivery lead time, or you can say the lead time, could be at least 1 week or so, right? Given our logistics and other things in place. So, anyways, that's actually one thing somebody can think about it. How is lead time responsible for the responsiveness, and how is lead time responsible for the contribution to the bull effect and the rippling effect, right? Then you have the production flexibility. It is 25 days. If there is sudden increase in the demand, there is sudden decrease in the demand. How much time do you take to react to the sale? Okay, how flexible you are. Okay, so this is very much related to the resilience. This is very much related to the resilience, right? Then cost, logistics cost, value added per employee, inventory days of supply. This is actually very high level metric here. Cash to cash cycle time, inventory days of supply. These are the complex terms. I do not know how many of you are really familiar with it, but due to time constraint, I cannot really get into that. So here you have the 46 days of your cash to cash cycle time. You can say 46 days means roughly 6 weeks. Here you have roughly 4 weeks. So 4 weeks of cash to cash cycle time. That means the time gap between money is received versus money is paid, or money is paid versus money is received. So that is what is the cash to cash cycle time, but there is a high level metric that we can calculate for this. So the asset terms are 12 terms and 19 terms. Okay, so how often you generate your revenue out of this. So as I said, there is a good study about the supply chain analytics by D. Oliveira et al. In the year 2012. So if you have any further interest to get into a kind of empirical study on what are the things being practiced in terms of analytics and whether it is contributing to the performance. Okay, now let's have a look at it. I'm not getting into too much about it. This paper I'm sharing with all of you. You can get into that. But what is that I need to say is, if you see this, the entire statistics here, the planning analytics, the sourcing analytics, the making analytics, the delivery analytics. So what is that is you are seeing here. So you see the source analytics, most of the places it is very significant. Okay, very highly significant here. That is your sourcing analytics. Here you have you can say this is sourcing analytics. Okay, I think here it didn't come properly. Otherwise, highly significant. So sourcing analytics, delivery analytics, make analytics are basically coming out with higher statistical significance in a typical form. And this is the study that covered 788 number of manufacturing companies. Okay, and this is the thing that they have found. It's a good study that you can see. And when you gradually move from a supply chain starting point to higher level over a period of time, then you become more mature. That is 1, 2, 3, 4, 5 supply chain process management maturity model. Okay, SCTM3. That is what they say. So when you start it, basically you manage your order. Then comes a distribution, demand, and production. Then procurement, process, strategic planning team here. Then you have customer integration, network design, and so on. Strategic behavior, responsiveness, as I said earlier, it's very critical. Then you have collaborative planning, forecasting, and replacement kind of thing. Okay, so once you move, it is going like this. So when you go like this, then what is your kind of adaptability to the analytics, and what is the benefit that you get? So here you can see the performance. Okay, and what is the performance? Mean is 3.12 out of a 5-point rating scale. Here you have the analytics score. Okay, I think here it is 3.23, 3.15. This is a standardized figure. Then you can see, the correlation between them. There are other tables I didn't represent much of time. So, given all this brief about the supply chain analytics, supply chain management, and a few related aspects in the analytics. So what are the things that are really happening in terms of, you can say, the supply chain management and the supply chain analytics, right? So I think some of the speakers might have already spoken to you about this. So descriptive, what is happening, and the prediction, that is what is going to happen, or you can say forecast. This plays a very, very crucial role in the supply chain, right? So if you see very closely, the supply chain is, you can say, struggling to minimize the forecasting error. Okay, and you may say no forecasting is correct. I do agree, no forecasting is correct. Okay, every forecasting will come up with its own forecasting error. Given that, we need to do something about it, right? Because knowing something about the future is better than knowing nothing, right? It will give us at least some guiding force, or maybe it will give us some idea so that we can proceed further for tomorrow, right? Then here you have time series and the forecasting methods. Okay. Then we have the machine learning techniques. You have many techniques available. The predictive models available, like logistic regression, decision tree based analysis, neural network based models, and so on, right? And this is one thing. Is actually most part of the things will come here. Okay, here actually you can say this is a supply chain forecast, or you can say the prediction that you do here. Okay, supply chain prediction that you do here, and what is that the decision you need to take in the process. So optimization, and you can also go for the simulations, right? It depends on what kind of question you have to solve. Okay, then you can decide on your methodology, right? If it is a predictive model, then you can go for simple predictive model to very complex predictive models, like we can say to start with moving average, exponential smoothing, and so on, to neural network based models, right? And here actually the linear programming based model to the simulation based models, and simulation plus optimization, that is also possible. But it's a very there are a lot of research happening on this simulation plus optimization, or optimization plus simulation, optimization plus simulation plus machine learning. So a lot of things are happening in that area also. So somebody can really think about it, right? Then based on a typical decision requirement at a typical stage, what are the stages? Planning is a stage. Then comes sourcing is a stage, making is a stage, delivery is a stage, and finally reverse logistics is another stage, right? A lot of great practices are happening. People are collecting their plastic bottles, wrappers, so that we can be environment friendly. Okay, and not only it is a practice from the company, or they are becoming more ethical. It is also at the same time the government regulations are coming into picture. They need to do something about it so that they will be more environment friendly. Right. Few things I do not want to discuss more about it, but what is that when you are going for a predictive model, basically what you need to do is the quality check of the data. That is very crucial. So you need to see whether the data has outliers, data has a lot of missing values and so on, right? Then given the things, you may need to code the data, right, to have more reliability. Then sometimes filtering, sometimes restructuring, or you can say like a matrix, row becoming columns, column becoming rows, and so on. Then the data transformation, how you convert the data to their normal values, okay, feature scaling, normality, or you can say standard normal variate calculations. All these things can be possible. And here you have the reliability check. Reliability check is nothing but I've shown you here. There is one Cronbach's alpha. This is one thing that we can calculate. Okay, this says the internal consistency of the items, right? Then you have the normality check. Normality check, you have the best way, if somebody is not familiar with, plot the histograms and plot the histograms. Then what you do is just you on freehand, just you join the midpoints. Okay, otherwise there are some tests available. Case test, Kolmogorov's mirror neuron test, homoscedasticity, heteroscedasticity, all these kind of things can be checked here. Then we can also go for a runs test. There are so many things for this normality check available. Then the model assumptions, right? What are the model assumptions? That we can say what is that kind of sampling that is essential, right? And what could be the nature of the variable? Then what is the right sample size and so on, right? Then there are few time series methods available, and also machine learning methods available. These are all 1 hour class. These are all 1 hour class. Moving average, exponential smoothing, Wolf's method, Winters method, regression, ARIMA and ARIMAX. Right? In the demonstration, I'll just show you this part. Okay. Of course, ARIMAX I'm not showing. ARIMA I'll just demonstrate. Then you have the ML-based models, the multiple linear or non-linear regressions, then hierarchical regressions, right? Logistic regression. These are all again 1 hour class. Support vector machines, tree-based models, the neural network, right? There's a lot of work happening here, neural network. Then you have also logistic regression, right? Then tree-based models, okay? Then there is no data available, then probably kind of a reinforcement kind of learning model that you can have. What are the checkpoints for generating a model is, these are the few things that you can keep in mind. Sampling adequacy, what is the right sample size for the analysis, right? And what are the typical number of variables that should be taken into the model, maybe a predictive model, how many variables should be normally taken into the model, or what is the right model, what is the right model, right? Then the normality and the runs, linearity, non-linearity, then multi-collinearity, right? Then homoscedasticity, heteroscedasticity, autocorrelation for the time series, okay? All these things should be taken into consideration for a predictive model, okay? So this is not about a predictive model class, this is a supply chain analytics class. Whatever is essential, I'm just trying to give you a kind of essence so that you can further proceed. And down the line, if you have any further queries or something, we can probably exchange mails or whatever, okay? 1.5 hours is nothing for this kind of discussion. The model fitting and the validation, you have a training data, then the testing data. How do you divide the data into training part and the testing part? Then you go for your go for building the model. Okay, when you go for building the model, there is one statistic that we basically take into consideration, that is R squared. Okay, that is also called as the coefficient of determination. The coefficient of determination, which is same as the square of the correlation coefficient, right? So you can figure it out, R square, or you can say R square is nothing but you can calculate the model that is not explaining whatever is that, you can say the prediction and what is the observation, you get the error, then you get prediction, or you can say observation minus, you can say the mean, then you take the square and divide, you get total error or total residual. So you subtract that from 1, it becomes R squared, right? R squared. So normally 70%, 60 to 70% is the right R squared for the empirical data. If you have more, then probably people may say there is bias that you may have to justify. What is that? Is the bias? You may have to take, you may have to divide the data and do a test for some kind of what is that? You can cross check. You can divide the data and show the figures and training and the testing. If there are very good correlation, then probably you can justify that the data is not biased, right? Then you have the standard error that you need to calculate. This is nothing but your standard deviation with respect to the sample. Then you calculate the root mean square error. Root mean square error is nothing but your y minus y hat, or you can say the y prediction. You take the square and take cumulatively the mean. You get RMSE. So these are certain statistics you need to put in place for your prediction model. Then you have the prescriptive models, basically optimization things. Not many people are using this kind of techniques, but I'm just giving you the idea about it so that you can, if you have interest, you can get into that. Linear programming based models, non-linear optimization based models, MILP based models, queuing models, okay, and discrete and stochastic simulation based models. This is one thing that a lot of work is happening here now. System dynamics, okay. Then the game theoretical models. Here also a lot of things are happening. Then you have dynamic programming, right? These are the few things that are happening in terms of the supply chain analytics. So there are the two cases that let me see how far I can go. It's 12:40 now. So one is the prediction that I'll just demonstrate you with the ARIMA, auto-regressive integrated moving average method using R. Okay. And secondly, there is one caselet that I've taken from Brian Mendel, that is about the network analysis. Okay, network analysis, and here would be LPP part. I am not very sure, but I'll just show you the certain things how I can, on trial and error basis, you can get the solution. Then you can also use LPP. I think time will not permit. This sheet I'll send you. You can have a look at it. So these are the few things as far as the analytical things are concerned. Now, what I'll do is I'll just take you to the next discussion on this, one prediction, one calculation for the network. Okay, what is the right network? So let me get into the discussion now. Before that, before I move into this, I would like to just talk to you for a while. Anybody has any questions on this? Okay, let me move. We can discuss maybe a little later. So for that, I'm just taking you to I've already shared with all of you. There are some codes that I've already shared with the madam, and she will be sharing with all of you. This is actually one model that is auto-regressive integrated moving average method, and we need to predict. Okay, I'll take a small data set. Here is the data set. I have already sent that also. There's the entire file. There's the list of files I have already sent to madam. One is a reading for you. One is my presentation. Another one is the caselet and the case analysis sheet, the data sheet. Then the R codes for generating ARIMA results. Okay, these are the few files I have already shared with madam, and I have requested her to share with all of you after the class. Then what happens here is, let me take you here. So there are a few things. I think some of you may be familiar with the R codes. If not, please get into the R codes. It may take some time for learning, but it's a good thing to move from SPSS to R and Python. So I'll just show you these things. Since time is short, if I type all this, takes a lot of time. What I'll do is I'll take the codes and I'll just put it here. Right now, I need to set the working directory. I need to read the data. Where is my data? Right, my data is here. So my data is here. So let me copy the path and paste the path here. Paste the path here. So you need to put the backward slash here. Okay, backward slash. That's the rule. So you need to read the data from there, right? So now we run it. Okay. So the working directory is set. Working directory is set. That means I'm going to read the data set from there. So what is the data set? I'll just show you. There is tractor sales data set I have taken from Kaggle and slightly modified. There is some problem with some version problem here. I'll just open it. This data that I have taken from Kaggle and there are a lot of data available from there. So I have just changed the dates. Okay, so it is actually the 12 years data we have on the cells of some tractor cells, right? And this is purely time series data, and you may have basically time series data or maybe cross-sectional data. If you have cross-sectional data, you can go for regression. If you have time series, you can go for RMM. If you have time series plus cross-sectional data, then probably you can go for Arimax. Okay. So, anyways, I'll just show you the auto-regressive integrated moving average method. That is, what is auto-regression? I'm not getting into too much about it. Suppose if I say your series is YT and there is another series that is YT minus 1, the before series that you have, that means what you are doing is you are trying to have a function. YT and YT minus 1, they are related. Okay. So if you want to have a regression model, then what you can do is you can simply take A plus B YT minus 1 and plus some error. This becomes your auto regression. Okay. Now you can continue. You can say B1 YT minus 1, B2 YT minus 2, B3 YT minus 3, and so on. That becomes your YT. Okay. Then similarly, you can have the error part. Error part here we have with respect to T. If you say ET, here is another part. Okay. So this ET can again come as a function of ET minus 1. Okay. This is another model. This is another model. So this is another part. So if you have this part again, then what will happen here is, let us say, so ET minus 1, then this is some constant. Okay. ET minus 1. Okay. Plus finally maybe some other error, right? So this is actually a kind of a model that you have, right? You can have this model. So now this is AR, up to this is AR model, and this part is MA model. Okay, AR model, and there is MA model. So AR plus MA becomes ARM model, ARMA model. Okay, if you integrate these two with the integration in the sense taking the difference. What is the difference? Difference is this is a series and this is another series. What you need to do is you take the difference. It is not differentiation, it is difference. Okay, this is delta YT, or in some of the books it says as DYT. Okay, so if you integrate this, then that becomes RMM model. Okay, so anyways, you can just try your hands with that. I'll just demonstrate how things happen. This is theoretical little background I have given on that. So let me go to my R. So I have sent the working directory. Now I need to read the data from there. Okay. So this data set, that is the tractor sales data set I have here, I need to read from there. Okay. So for reading, what I need to do is I need to set my data. What is my data set? I need to read from there. So I've set my working directory. There is no issue with the path. Path is already selected. So I'm going to read the data, that is a CSV file, which is a comma separated values. Okay. So the CSV file, most of the data sets are basically on CSV. So it is read.csv and the file name. Very simple. So I'm going to read it. Okay. If you want to see what is there in the data, then you can type data and you can simply run. Now whatever is there in the CSV file, I got it here. Okay, I got it here, right? All the data sets are there for 144 observations, and these are the cells. Now, next is I need to declare the data set is a, because R does not know whether your data set is a time series data set, or you can say it is some of the data set, right? You need to declare. So for declaring, what you need to do is you need to set data is equal to time series. Okay, you can try your hands with different frequency and other things due to paucity of time. I just to show you how to run it. Then you can keep the things changing, because I have already shared with madam. You can try your hands maybe leisurely while you are at home. If you have any questions or something, you can call me or you can mail me. Maybe you will be in touch. So now I run it. Then I have generated the data, or I said the data is a time series data. Now I would like to see how the data is displayed. Okay, now you can see there are 12 frequency means 12 January to December in a typical year, and the data set is from 2007 to 2018. Of course, I have changed these values because the Kaggle data set was very old, so I just made little change there. In terms of the time only, I didn't change any values that are there in this cells, right? Because this may be the real data that the Kaggle has collected. They also go for a lot of competition. Maybe you can browse, and there are a lot of work happening in the GitHub. You will get a lot of data sets from there and exercise. So anyway, these are the few things that we have taken. This is the data set, and this is a time series data set. Second data I am just reading. Second means 2 means in the second column. Second column is represented by the cells. Second is second column representing the cells. So I'm reading that, and starting here is 2007. Okay, and that is the first period. Then frequency is equal to 12. So I'm taking data up to 12 months. Okay, after 12 months, data is again repeating. So in the time series and the forecasting analysis, you might have come across two things. One is the seasonal fluctuation, and another one is the cyclical variation. Okay, seasonal is basically typically in a year, and cyclical is basically within or maybe from year to year, right? So there are a lot of ways somebody can calculate. Okay, and at the time I would have shown you how to calculate all those things. But anyways, you can slowly see how things are happening there. Then after you demonstrate your data, then you may be interested to see what is your data that is varying with respect to the time. So now you just generate a plot the data. X-axis is the year, Y-axis is the cells. Okay, very simple command. You do not have to really struggle for writing this command. Very simple command, but you have to be very careful with sometimes the apostrophe or maybe quote symbols. If you don't give the quote symbols, it will not read, right? Then you can see this particular data set, right? So what is that you see from here is, if I maybe it's slightly difficult, you can see there is a trend, is increasing trend, and within a typical cycle, there are fluctuations. This is a cycle, this is a cycle, this is a cycle, this is a cycle. All these are cycles. How many years will be there? I think 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 into 12, 144 observations that we have. So we have seen one thing, the data has a lot of, you can say trend, and the data has a lot of seasonal fluctuations. Okay, seasonal fluctuations. Now, after this, we may need to evaluate what is the trend, what is the seasonality, what is the randomness. Okay, we can do that. Okay, but how to control this particular one? We need to do one thing that is called as differencing. As I said here, yt and yt minus 1. Okay, so you see, let us say this is yt. You have some data here. Okay, now yt minus 1. That means first place will be coming to the second place. 1. This is called as 1 lag. Okay, now here will be coming here. Here it will be coming here. Here it will be coming here. Okay, now so from here to here, if I say this is 1, 2, 3, 4, 5, and so on. So that means I have complete information from second observation. From second observation to nth observation, I have the complete information. Okay, so this information, if I take into consideration, then this is one array, and here is another array. So if I take the correlation between yt and yt minus 1, then this becomes your SEF, autocorrelation function. Okay, so this autocorrelation function I can calculate from this analysis. Okay, so now here what is happening is when there is a high autocorrelation, and then what you say is high autocorrelation is normally not accepted. Okay, high SEF is not permitted. Okay, let us say 0.95 or so, right? So it is not permitted. That means you need to now control. So how you can control? Controlling this is very easy. What you can do is YT series and YT minus series. If you can subtract this, then you get the fast differencing. This is a case for fast differencing. Similarly, you can say second differencing. Okay, this is giving you one result. Similarly, you can have YT minus 1 and minus YT minus 2. This is giving you another result. Okay, now if you subtract this and this, then it will become second order differential. Okay, like this you can proceed. First order differential, second order differential. Okay, now the idea is to reduce the what is that non-stationarity part of it. Non-stationarity means this is a non-stationary series. This is a non-stationary series. That means the fluctuations are happening. Okay, and with trend is showing increasing trend, and there is a lot of fluctuation from cycle to cycle. Okay, we need to minimize. Now, how we can do that? You see, I'm leaving this step number 2. You can just try. I'm just doing this differencing part. Okay, you can see what is the benefit of this. What is the benefit of this? So, the differencing part will minimize the trend. Now you see there is no trend. Almost there is no trend. Okay, I'll show you this two comparison. See this data. Okay, and see this data. Okay, so here there is trend. Here there is a lot of trend. Okay, and here there is almost a trend is not there. Okay, but what you see is variations are there. There are a lot of variation in a typical cycle. Lot of variation. So you need to control this variation. Controlling this variation means how to control? Means the data size is impacting the variation. Okay, or you can say the standard deviation that is showing you this variation. So one good idea to convert this high fluctuations to low fluctuation, you can take log treatment. I have taken logarithmic with base 10. So if you take log 10 treatment, then you can see what is the benefit. Okay, if you take the log 10, then you can see what is the benefit. So you can just do that. You can see now. So I will show you. I'll compare these two. You can see this chart. You see, okay, there is a trend. There is a trend. That means trend is less here, more here, more here, more is highest here. But in this case, there is no trend. All the cycles are almost equal. Amplitude, or maybe you can say the crest is almost equal. All the cases. Okay, that's the difference. Now, what is that I'm going to do is, I'm going to combine these two aspects. I'm going to combine these two aspects. I just I'm going to combine these two aspects. One is coming here. Anyways, so I'm going to combine these two. One is, you can closely watch, differencing. Okay, differencing the data. Then I'm taking the log 10. Then I'm taking the differencing. So two things I'm clubbing together. Other things are usual. So now you can see there is. Now you compare this chart with original chart. See, it has trend, it has seasonality. But you see this, there is no trend, almost zero. Okay, or a mean line here. If you plot, there is no trend, or maybe very little trend. Then seasonality also came down. Okay, you see this picture again. Okay, lot of fluctuations from time to time. Both have control here. So that is the beauty of this logarithmic treatment. The two treatments that you can do. One is the differencing treatment. Okay. Another one is log treatment. So if you do these two for any data set, then what will happen? Your trend and seasonality will reduce. Okay, and this is one kind of assumption for the time series, or this is a necessity for the time series. Okay, so that is why we are doing this, right? Now let me get into the next step. Then I'm interested to see what is my SCF and what is my PSCF, autocorrelation and the partial autocorrelation. Okay, I just need to see autocorrelation. This is the autocorrelation function. What happens? Autocorrelation, I have already told you. Autocorrelation is nothing but your yt minus 1. Yt series, okay, is going with yt minus 1 series. You just take the correlation. You know how to calculate the correlation. Okay, x covariance you can calculate. Okay, then you can calculate with the respect to the standard deviation of x, standard deviation of y, right? So with that you can calculate your or you can say 1 by n, right? That way you can calculate your the covariance, right? Divided by sigma x, sigma y, right? That way you can calculate your correlation. You know, it is sigma xy, right? By sigma x, sigma y. This way you can calculate, right? So this is correlation. When the series is same, with a different lag, that becomes your autocorrelation. And if you regress this and this, you get partial autocorrelation. So that is how you need to calculate. Okay, that is how we need to calculate SCF and PSCF. So what happens here in this particular picture is this is like a lower confidence limit. You know, in a normal distribution there is confidence limit from statistics. I think someone will be familiar with it. So plus or minus 1 sigma covers 68% or 68.27%. Plus or minus 2 sigma covers 95.45%. Plus or minus 3 sigma covers 99.73%. Okay, so this is the lower limit and this is the upper limit. What is that you see is there is a lot of autocorrelation in the this is 0th lag. Okay, this is the 5th lag, 10th lag, 15th lag, and so on. That means yt minus 1 I have taken. You can say yt minus 2 series, yt minus 3 series, yt minus 5 series. If the data is big, you can play with the numbers. Otherwise, no. Then what is going to happen here is you have fast lag, or you can say at this 0th or the original series and yt minus 1 series, there is yt and yt, right? The 100% correlation, right? Then fast came down, second came down, third, fourth is all under control. But sixth, again, shooting off this lower confidence limit and the upper confidence limit. Similarly, 6th, 7th, 8th, 9th, 10th, they are under control. 11th is going off. Then 12th, 13th, 14th, 15th, 16th are under control. 17th is shooting up the mark. Okay, likewise, you can see. Similarly, another one is PSCF. Similarly, another one is the PSCF. So this PSCF, partial autocorrelation function, that you can see here. So here also the same thing. Here the 6th one is going out of the range. It is like people from the operations may be knowing, like a specification limit in quality, we say. So lower confidence limit, upper confidence limit, or lower control limit and upper control limit. So here there is going out. Here it is going out. Okay. So now we need to control this. Okay. And this is nothing but your things that you have calculated in this case, where SCF and PSF are like this. Now what is that I'm going to do is I need to calculate my forecast. So best way, maybe people may be familiar with how to calculate moving average. You add this 3 or 4, you can say you can take average. Okay, you can take average of this 1, 2, 3, 4 or 3 period, 4 period average, you can say. So this is like your this is like one series that you get. Okay, and this is nothing but your forecast. Okay, so you can calculate your error and so on. and error is nothing but your simple sentence. Here we have no data. Here you have this is the actual, and this is your calculated. So this is the error. So this way you can calculate, right? I'm just showing you. I'm not going to complete this. Just I will not commit it. You may be familiar with it. Then what happens here is okay. We have calculated. Now the next thing that we need to do is we need forecast. Okay. So you just require forecast. That is the forecast package here. So you run it. If in case it will not be there, then it will be, in my case it is available. In case it is not there, then what you can do is install that package as forecast. It will install the package. Then I need to calculate my ARIMA model. Okay. So ARIMA model, you do not have to write many codes for this. Actually the code is already written auto.arima. So you just need to put it here. Okay. And for all predictive models, or especially the time series prediction models, please go through the Box-Jenkins methodology. That's a very nice topic, and moreover, the forecasting method by Mokridakis and others. That's a good book. I think I have mentioned in the reference. So if you do that, then I got my ARIMA models. Okay, I got my ARIMA models. So ARIMA model, I got all this, and here is my Bayesian information criterion. What is my Bayesian information criterion is that this is actually a kind of statistics that we need to have for controlling, or I can say we need to have a best ARIMA model. Okay, so that is one thing that is based on, you can say, the BSC. That is based on the BSC. That is that is based on the maximum likelihood estimation. It is based on the maximum likelihood estimation. That BIC is something that you can. So the BIC is Bayesian information criterion. Okay, that is actually based on the maximum, I can say mean square error here, MSE, plus here K times ln. That's the natural logarithm divided by K is the number of parameters, N is the sample size. Okay, so this is one thing that you can calculate. Okay, this is mean square error. What is mean square error? Mean square error is y minus, you can say the y prediction. Okay, y prediction, right? So this is the error. If you take divided by n, you get your mean square error. Is to square it, right? Then RMSE, we need to take the square root of this. Then you can calculate this. Then another criterion is something called Akaike information criterion, that is AIC. AIC is something that you can calculate with respect to your likelihood, 2 log likelihood, okay, then plus 2 times K. Then 2 log likelihood is something that is very, very due to your you can say n into 1 plus logarithmic base 10 2 pi. Okay, and this comes with plus your n log sigma square. Okay, so these are the two things will be used for the best fit ARIMA models. There are other things also, econometric things like what is that, the unit root test and so on, but we are not getting into those things. So here we have seen. Now, if you compare the results, here, what is the minimum? What is the minimum? This is the minimum, minus 702.6033. This is the minimum. So that means this is the best model. What is the best model? This is ARIMA 011 011 12. This is the best model. So best model is this model. So you have calculated. Now, what is the next thing that I am going to do is I need to have my model. Summary ARIMA fit. Summary ARIMA fit. I need to get my model. So just you copy it. Slowly you can develop the skill to type your own code. So best model that I got my model here. The MA part and SMA part. Okay. So MA part is this, and SMA, that is you can say the seasonal moving average part this. Okay, so you can have a model from this. Okay, now AIC and minus 702.71, as I said, this is the best fit model. Okay, that is 011 011. 12 is nothing but the frequency. 011 011. So I think it should be there. Yeah, 0, 1, 1, 0, 1, 1. This is P is 0, Q is 1, P is 0, Q is 1, D is 1, difference is 1. And this is frequency is January to December, right? Now you got this. So what is the error part? The mean error, you know that how to calculate mean error, then root mean square error, maximum absolute error, mean percentage error, mean absolute percentage error, then mean absolute standard error, then here autocorrelation function. Autocorrelation is very, very low here. Autocorrelation is very, very low here. So in this way, we can do that. Now my target is to get the forecast. So how can I get the forecast? I want 4 months prediction. So what is the 4 months prediction? RMR fit n dot ahead is 4. So what is my prediction here? I'm just showing you. My months are ending at December, so I can drag it further. January, February, March, April. Okay, I want values for this. I want values for this. So this will be my prediction for this particular model. So how to do that? Now I'll run this part. Run it. Now I want prediction. Okay. Now I predict. So what is the value that you are going to get here is So why this? Okay. So this is my January 2019, February 2019, March 2019, and April. So I got my figures. Now one thing you see here, they are all 0 point something, which doesn't have any meaning, right? So why it is coming? Because I have taken log treatment for all the data points of the series. Now I need to convert it to 2 to the power I need to raise this forecast to 10 to the power this. Then I will get the right value. So what I need to do is I need to get my prediction raising up to the power 10. So then 10 to the power something, if I raise the value, then I'm going to get my prediction. So what is the prediction now? You type red, then you see. So this is coming as your okay, then January 567, I can simply copy and paste here. Okay. So 567 point, this is my this forecast. Then 566 point, this is my February forecast. This is my March forecast. This is my April forecast. I remove all the decimals. So this is my forecast that I got. Okay. Now, okay, I don't save here anything. This sheet will be again. It will be asking for a lot of changes because this is a CSV file. So then the next thing is that that's done. Then comes is I need to see if any further extraction is possible. What I need to do is I need to find out the residual. What is the residual is nothing but the error. So I need to check if there is any further information available. What I need to do is I just see the residual. Now you can see, except this is the first part. Okay, you can compare these two charts. This is the first ACF. Lot of points are or correlations, auto correlations are out of the range or out of the specification limit. But here what is happening? They are all under control. They are all under control. So there is no further extraction possible or detailed, right? Then similarly, I can check my PACF. I can check my PACF. Then I can go for it and see they are under control. You can check the PACF previously. See, this is out, this is out, this is out. So what is happening is this is under control now. Okay. Now, if you see the SCF of the original data, I'll just show you SCF of the original data. Okay. Now you can see the SCF. So there are high auto correlations everywhere. Okay. Similarly, you can see the PACF also. PACF data, if you see the high. Okay, many points we have the PACF. So they are under control now. Okay. They are under control within the specification limit, or you can say within the control limits. Okay, no issues. Now I can use my prediction for the decision making in the supply chain. Now I want to see whether my box is Jenkins or Leading box statistic. Leading box statistics is saying whether the information or whatever the results that I got is appropriate and can be used in the decision making. So I can see the Leading box statistics is actually the statistics that comes from the autocorrelation function. You know that autocorrelation is something that there are two things. One is the Q statistic. One is the Q statistic. Q statistics is something is a very simple number of observations, and you just all the autocorrelations you just add I from 1 to k. This is called as Q statistic. And when you go for this test, what is that is expected is H0, that means p value greater than 0.05 is needed. This is needed. Don't be under the impression that alternative hypothesis is essential. We need H0 because the data would have come from the normal statistic, normal or you can say normal population. Then there is another one, that is Lejeune box Q statistic. Little refinement of this. What is that we are going to do is we are doing simply one small thing here. This is n here. Another value that we are multiplying with n plus 2. This is according to the empirical result. Then these things will be there. This is your you can say RK square. Then you have one thing that n minus k that you are doing. K is varying from, let us say, some 1 to, let us say, some value 1 to, let us say 1 to k, or maybe 1 to some value. So then it is same autocorrelation you are adding with the different lags. Then here you are subtracting n minus k. N is, you can say the n is the sample size. N is the sample size. Then k is the number of parameters. Okay, then you will get. So this is again here the hypothesis says the model does not show the lack of fit. The model does not show the lack of fit. That is your hypothesis. Okay, the alternative hypothesis model shows lack of fit. Model shows lack of fit. That is HA P is less than 0.05, which says the model shows lack of fit is not required. We need this. Okay, we need this. Model does not show lack of fit. Model does not show the lack of fit. P value greater than 0.05. The type 1 error should be more. Type 1 error should be more, right? Then we refer that we say that model does not show a lack of fit. Then we can proceed with our results. Okay. Now, if we take this, what is the p value? We have taken the p value is equal to here 0.4585, which is greater than 0.05. So whatever results we got here, we can use it for our analysis. Here I have taken lag 5. If you want, you can change the lag to be 2, and you can regenerate. Still, the p value is greater than 0.05. You can use this. Okay, and this way you can say that your prediction is more or less it is a good prediction, and you can use this for your for the decision making in the supply chain. Now, one thing here I'd like to show you. Those who are further interested for learning on this part, please go through this book. It's a good book, and for the prediction. And further, we have one more good book here on the machine learning, that is by James G and Witten and others. So it's a good book. Okay, these are very standard references I have kept here. And for supply chain, this book and this book. Okay, I refer to these two books. One is from the analytical viewpoint, another one is from the practical viewpoint, right? And optimization is a good book, and you have H.A. Taha also, that's a good book. Then one paper I have kept here for your learning, that is how analytics is helping the supply chain in terms of its performance, and what is the result. Okay, so there are a few things, standard references I have kept. Each of these references are very, very crucial from the viewpoint of the analysis. And also we have something called, partly we have here simulation. Okay, and you have a lot of softwares available. You have Benzene, you have Arena, you have Scheibel. Many softwares are available in terms. Even the Excel sheet also you can generate the random numbers, Monte Carlo simulation kind of thing also you can do. So these are the few things, and please go through these references. Okay. So this is my one part, and as I said, madam, I may take. I think already it is the time on 15. I said, madam, I'll take 15 minutes more because that part is still pending. I'd like to take permission from madam. Madam, can I take further some 15 minutes?
Sir, yes, sir, you can continue, sir.
Okay, fine. So let me go to the second part of it. Let me close. Everything is shared with you. You can just do yourself by simply try your hands with copying and pasting in the what is that R console, right? And slowly try to learn yourself, because unless you type this yourself, it will not be that easy to understand how things are happening. So it is not that user-friendly kind of software. A small quotation mark will not read the data properly, not execute the data properly. Okay, similar is the case with Python. So I'm closing this part. Please do that. That's my first part. Second part, just a moment. So I'm just closing. So you can do that. Now, the other part is here. Okay, I just wanted to quickly demonstrate. Okay, so this data that says it's a network analysis, and this is a part of your you can say prescriptive analytics, or you can say optimization, right? And here you can integrate the machine learning, you can integrate what is that simulation and so on, right? Now just have a look at it. There is a company who is selling basically sports items, and these are the demands. These are the demands in the year 1999. Okay, so it's basically the data from USA, northwest, southwest, upper Midwest, lower Midwest, northeast, southeast. So this data, right? This is the demand, and the company is basically trying to choose a warehouse, okay, in these locations, for delivering the items to these locations. Okay, how many locations are there? 6 different markets and 5 different supply sources, or you can say 6 different distribution markets, or you can say the consumption market, and 5 different supply markets. Now the company has to send the material from these places to these places. So what is the right network for this? What is the right network for this? Now that is the thing. And as far as you know, that warehousing is a bigger concept than inventory management. Warehouse has many other things to do in terms of value addition. So that is why the current generation warehouses are called as fulfillment centers, FCs. So here you have any warehouse, you can be categorized as a small warehouse, or it can be categorized as a large warehouse. Okay, small warehouse, large warehouse. Now every single warehouse has a fixed cost, variable cost, and its capacity. So large warehouse also similarly, it's a fixed cost, variable cost, and the capacity, right? So small warehouses can accommodate up to 20 lakh items, irrespective of their locations. Similarly, the large warehouses can accommodate up to 40 lakh units of items, irrespective of the capacity, right? Then, as you know that every single warehouse has some fixed cost, so it is 3 lakh dollar. Everything is in dollar. For simplicity, I have removed the dollar part, or the symbol dollar here. So $3 lakh, $2,50,000, and so on. So these are the fixed cost. And what is the variable cost? Every single unit comes to this warehouse will have a variable cost of 0.2 US dollars. Okay, let us say one item is coming into the warehouse. What will be the cost for that? The $0.2. Okay, that means 10 items are coming, means $2. So $2 is translating into 180 rupees approximately, or you can say Indian rupees, right? Then these are the capacities. These are the capacities. Similarly, you have large warehouse also. You have the variable cost same. For simplicity, it is same here. So, but due to economies of scale, it may be less. It may be slightly less. Let us keep it aside. Then these are the two things given in terms of small warehouse data and the large warehouse data. Then comes your shipping metrics. Okay, you know that from any place, let us say these are the supply sources. I have already told you these are the supply sources: Seattle, Denver, then St. Louis, Atlanta, Philadelphia. These are the supply sources. What are the consumption markets, or you can say the buying markets? Northwest, Southwest, Upper Midwest, Lower Midwest, Northeast, and the Southeast. These are the markets. So we are supplying the material from here to here. So this is a transportation matrix. People who are familiar with the optimization techniques may be knowing this is the transportation matrix. Now what happens here is in this case, the company wants to know if all the warehouses are or all the requirements of various markets are done, or maybe all the fulfillments, if they are done from St. Louis warehouse, then what will be the cost? What will be the total cost? So that is broadly the, you can say that is broadly the idea. And I'll just open that also here. This is I have taken directly from the book, that is Sopra and Mandel. This is a very simple thing, but there are a lot of analytical aspects in it, right? This itself is 1.5 hour discussion. Okay. So, anyways, so one thing I would like to quickly say, all this I have already told. Here, if there is an item coming to a typical warehouse, then what will be the holding cost? What will be the holding cost? The holding cost is they have empirically calculated. The holding cost is this. I'll show you. The holding cost is equal to, that is the 4,75,000. Okay, that is the fixed cost plus 0.165 into the flow of the items that is happening to the warehouse. So this is actually the thing that is happening, right? Now, so what is that we need to calculate? There are a few things we need to fill this blank spaces. We need to calculate what is the warehousing cost, what is the inventory cost, what is the shipping cost, and one more thing here, what is the shipping charge, right? That means there are two things here. One is the shipping cost. One is the shipping cost. Shipping cost means what you spend. Shipping cost means the company spends. Okay, this is the company spends, right? And there is shipping charge also, that is charged to the customers. Shipping charge. Shipping charge. This is actually borne by the customers. Okay. So every single shipping cost, that means every single shipping cost has the I can say 4 items. 4 items. One shipment is equal to 4 items. One shipment is equal to 4 items. Okay. 4 items are there in a single shipment, right? So that is one additional information the company has given. Now, how to calculate all this? Just based on our trial and error method. Somebody can do it in the linear programming that I'll share a little later. So warehousing cost is here. What is the warehousing cost that the company has to calculate? Before we calculate the warehousing cost, what is that we need to do is we need to calculate what is the total demand that is fulfilled across the markets from the typical warehouse in the St. Louis, right? So what is the total demand that is fulfilled? Let us calculate from any place or in these 6 markets, what is the total demand that is fulfilled from a typical place to all these places. Okay, now you take the total demand. Total demand is calculated to be 14 lakh 25,000 is the total demand. That the company has estimated the total demand is 14 lakh 25,000, right? Now, after you calculate this, then we need to calculate this many costs. Okay, what is the warehousing cost? What is the inventory cost? What is the shipping cost? What is the shipping charge? What is the total cost? Right. So, what is the total cost? If I say total cost is equal to this one plus warehousing cost plus inventory cost plus shipping cost minus what you charge to the customer. Okay, what you charge to the customer. I kept it to dollar, so let us remove it. Okay, so initially there is nothing there, right? Now, what is that you need to do is warehousing cost. So, what is the warehousing cost? For the warehousing cost, we need to calculate what is the total total fixed cost at St. Louis. What is the fixed cost if we, well, let me remove it to make it, let me highlight this. We are considering about this part. Okay, let me give a different color to this. Okay, this part. So the company is deciding to deliver every single thing from St. Louis. Okay, we don't know what is the reason. Maybe because of its network, or maybe what is that geographical advantage of the St. Louis, or maybe it I can say centralized mode of distribution or decentralized mode of distribution. We do not know that. The company says St. Louis. So the St. Louis, then what is the total thing that it is delivered from here? Now, before we decide on this, we need to see which type of warehouse is needed. Which warehouse is needed in this case? Okay. So whether it is small warehouse needed or it is a large warehouse needed. So what we can see from here is, since the total demand is 14 lakh 25,000, okay, which is lower than 20 lakh, then one small warehouse can do the thing. One small warehouse can accommodate the deliveries from let us say from St. Louis. Right? Now, so we decide on one small warehouse. Once we decide on a small warehouse, then let us say small warehouse. What is the cost? The cost is, I just keep the cursor here. Let me increase the size a little bit. Okay. So the fixed cost. Any location has a fixed cost. So what is the fixed cost? This is the fixed cost. 2,20,000 for a small warehouse in St. Louis, plus the variable cost is this one 0.2, or you can say $0.2 into what is the amount that is flowing from that warehouse, 14,25,000. Okay, then what is the value that you are going to get is this one, right? This is 5,05,000 US dollars that the company is going to spend as far as the warehousing cost is concerned. So one is the fixed cost, that is 2,20,000 US dollars plus 0.2 into the amount that is flowing from the St. Louis warehouse to all these places. That I can say 3,20,000 to northwest, St. Louis 2 lakh, upper Midwest 1,60,000, and so on. So total is 14,25,000. So this is the cost that we calculated. Then comes is the inventory cost. Now for the inventory cost, as I told you earlier, they have statistically they have seen, or you can say they have seen a model which says the inventory cost or the holding cost. That holding cost plays a very crucial role in the inventory management, and the holding cost is depending on the weighted average cost of the capital. Then comes occupancy cost, then storage cost, and other things like obsolescence cost. People from operations area may be familiar with it. So then they have statistically calculated a regression equation for their inventory holding cost. So inventory holding cost, there is other one is the transportation cost, the ordering cost. So inventory holding cost is equal to, they have calculated statistically 4,75,000 is like a regression equation plus 0.165 into flow. whatever is the flow from here. Okay, now let us use this information here in the Excel sheet. This is equal to, I'll just type 4,75,000 is the fixed cost plus the variable cost is 0.165 into the amount that is flowing to the warehouse, that is 7,10,112. So okay, 7,10,125. So this is the inventory holding cost that we have calculated. Then comes is the shipping cost. For the shipping cost, we need to see there are two areas. This is one area that is the delivery. Okay, that's the delivery that is happening from this warehouse. Okay, this is sorry. The delivery that is happening here is not this. Delivery is here, right? Delivery is here, right? And this is a total. I don't need this now. So this is one area. Secondly, if every single thing is delivered from this warehouse, sent to it. So this is the cost that you are going to spend. So this is another area. So this is the sum product of these two, right? So that means what you need to do is, this is 1 unit of material from St. Louis warehouse to a location in northwest will take $3.5 US. Okay, one shipment from St. Louis to southwest will take $3.5 US. One shipment from St. Louis to upper Midwest will take $2.5 US. So these are the things. So now how do we calculate? This is sum product of this array and comma this array, right? These are the two arrays. Then this is actually for 4 different items. Okay, so each unit you need to calculate. Each unit, what is the cost? If you divide by 4, then you get what is the total cost for each unit. That means these are for 4 shipments. If I say this is for 4 units, this is the cost. Okay, then what I need to do is I do one thing here is equal to this divided by 4. Per unit you will get the cost. So you can do that, right? So per unit, what is the cost? Okay, so now this is our matrix. This is our matrix, and this is the matrix for the demand. Now, if you take the sum product, you should get that value. Sum product of this demand fulfillment, comma, and St. Louis, if all the warehouses are located at this point, then you get this. Okay. Now, just to cross check, this value minus this value, you get 0, right? So this is correct. Now, this is one thing that I have shown you. So this is for cross check, not needed for the analysis. So, okay, let me keep it here. Unit shipment cost per unit. Cost or transportation cost, you can say, per unit. Okay, so this is the matrix. Now, last part is the shipping charge. You need to get the shipping charge. What is the shipping charge? Shipping charge is the same thing, but here you are actually getting what is that? $3 you are getting for shipment. For shipment, you are getting $3. So what is that you need to do is the same thing. What you need to do is sum product of these two arrays. Sum product of this array. This is the demand. Okay. Then comes comma this array. Okay. Then divided by 4 you can do, and you need to multiply $3 per shipment, or you can say per unit. You can say per unit the company is getting $3. Okay, so that means 3 by 4 plus each shipment is 4 units, so you get per unit. Per unit, what is that the company is getting from the customers? Okay, or in simple sentence, what you can say is this one. Just a moment. This is actually the total demand, okay, that you can do one thing. Otherwise, what is the total shipment? 14,25,000 is the total shipment. Then in this, how many shipments? Okay, how many shipments you get? Okay, so you divide by 4. Each shipment is constituting 4 items. So these many shipments. Okay, so these many shipments if you do, then what is that per shipment you are getting from the customers? 3 you are getting, $3 you are getting. So what is that? 10,68,750. So I can directly get this value there. 10,68,750 that you are going to get from the customers. So how to calculate? This is plus this plus this plus this. Okay, that means is equal to this one is your warehousing cost plus inventory cost plus shipping cost. This is the total cost. Then what is that you are charging to the customers? This one. Then what is the net you are spending? This minus shipping charges. You are spending 12,54,500 is your total cost, right? So this is the one way of calculating this cost. Now, your task is do this exercise for 2000. Do this exercise for 2000, 2001, 2002. This data is very old, but don't worry for that. So you need to calculate these 4 things. Okay, given the demand is increasing at the rate of 80%. Okay, so that means if the demand is increasing at the rate of 80%, you need to multiply 1.8. You calculate. Okay, same thing will be happening here. Same thing will be happening here. Same thing will be happening here. Okay, so you need to calculate now what is the total demand. Here we have calculated as 14 lakh something. Sum, if we calculate, this is your total demand. Then you can calculate your demand. Okay, so now your task is 25,65,000, 46,17,000, 83,10,600. You need to calculate. Same thing. You need to repeat whatever we have done here. You need to repeat and see how things are happening. Okay. Now this is one way of doing the things. Now further there is a task for you is to choose. Okay, to choose. Okay. So let's say small warehouse, large warehouse. Okay. Here you want to choose, let us say, one small warehouse or one large warehouse. Then 2 small warehouses or one large warehouse. Okay, or these are the combinations. Then small warehouse and large warehouse. So one small, one large, right? One large warehouse. So all these things we need to do across 2008. Sorry, here it is 2000. I think data is 2019, 2000, 2001, 2002. Don't worry for this old data. 2002. Okay, you need to do this. Okay. Now you will be coming to know whether setting of the warehouse at St. Louis, which is a centralized mode of distribution. Centralized mode of distribution is a good idea for the deliveries. Okay. Now there is one thing that is pending that will take a lot of time. That is linear programming. We need to write the constraints, objective function, and all the equations for the LPP. Takes little time. Another 1 hour may be needed for this. So what I'll do is I'll share you one Excel sheet calculating this. Maybe people who are familiar with LPP can understand. Otherwise, you can simply leave it. Okay. So with this, I would like to. It's already 1:40. I should not take more time. I said, madam, I may take 15-20 minutes more because always this kind of subjects take more time. So for the benefit of the class, I took a little more time. Otherwise, I could have completed early. So there are a lot of analytical aspects to find out to a lot of analytical aspects that we can do in terms of operations, supply chain management, quality management, and so on. But not many people take this as a route for the research. Many people are either HR or marketing or finance. So maybe in case you are a researcher working on this area, we can be in touch in future for mutual benefit. And it's not that we only take classes, we also do attend classes for our own improvement. So if you have any opportunity for us, please let us know. We'll be part of that. So thank you very much, and I wish you all the very best. Over to Madam.
So thank you, sir. Thank you for your elaborative lecture on supply chain analytics. It was our pleasure to have you here today, sir. And you did an excellent job regarding the explanation related to the concepts of supply chain management and analytics, and the examples that you illustrated are very good, very excellent, sir. So very nice to have you here today, sir. Thank you very much on behalf of JNTUA School of Management Studies and the organizing team, sir. Thank you.
Yeah, thank you very much, madam, for the opportunity, and see you again in some other platform. And I wish all.
It's our pleasure to have you another time, sir.
Okay, thank you, madam. And one request, madam, whenever you are giving me a class like this, so at least 2 sessions is needed, madam. At least 2. Because there are a lot of things mathematical and also not it's a lot of statistics, mathematics, and like a combination. So it's very difficult to cover in 1.5 hours. I don't know. I don't know. People might have felt that I am going very fast and so on. But we need to do justice also to your invitation, right?
It was clear, sir. Whatever the concepts that you explained, the illustration of examples, that was clear. But due to some constraints, we didn't go for 2 sessions, sir. So we have to touch on all the introduction parts related to the analytics. So that's why we have allotted only 1 month session for all. So we look forward you for next session. FDPs also, sir. We will solicit your cooperation and support, sir, for all the FDPs that we are going to be conducted for the further months of further upcoming years also.
Okay. Madam, can I have a quick feedback from one of the participants? Quick feedback?
Yeah, sure, sir. Yeah, sure.
One of the participants, if you are listening to me, can you just give me a quick feedback? So that it will help me to further redesign my things.
Participant, you can unmute yourself and talk. The sir is asking for feedback related to the supply chain analytics session.
Madam, I think you'll be taking the feedback, right? You'll be taking the feedback, right?
Yes, sir. I'm taking, sir.
Okay.
Actually, I have provided a link to all the participants regarding the session, attendance and feedback, both, sir.
Okay, madam. That's fine then. That's fine. Thank you very much.
I will forward you to your sir.
Okay, madam. Thank you very much, and I wish all the participants all the very best. So be in touch. Maybe sometime down the line we'll catch each other. Thank you very much. Good luck to all of you. Madam, I will just leave the meeting.
Yeah, sure, sir. Thank you, sir. Thank you for your time and concept explanation related to supply chain analytics. Thank you very much, sir.
Thank you, madam. Thank you. Yeah. Have a good day.
Yeah. Thank you, sir. You too, sir. Yeah, participants. Already it's 1:40. So we'll have the next session by 1:45. We'll have the next session by 2:15 p.m. sharp. Actually, madam is also waiting to join so that we can start the session by 2:15. Please be patient due to the busy schedule and the maximum coverage of the syllabus. We are extending the time. So please finish your lunch and reassemble by 2:15 p.m. Thank you.